Okay, so the first question, this is 2.2, is number 6, log base x of x to the 7th. Log base x of x to the 7th. So the very first thing that I want to do is I want to translate this into exponentials, because if I can translate this into exponentials, then it makes much more sense. So I'm going to say this is equal to, and I'm going to put a box right here, right? Okay. I put a box right here. So if I was going to write this as an exponential, right? First, I take into account what is my base. What's my base right here? Yeah, it's x. Very good. So I'm going to write a big X because that's my base, right? And then I'm going to write the exponent, which is on the other side of the log, right? Because remember, what logs help us do is find the exponent. Logs help us find the exponent. So x to the what, right? So let me play matching really quick. This little x here is this big X here. This box right here is this box right here. And then equals to, this guy right here is this guy right here, okay? Is equal to x to the 7th. What do you guys notice? So x to the 7th. What do you guys notice here? I want to know what this is. What goes in that box? Play matching. Yeah, 7. 7 has to go in that box. Why does 7 have to go in the box? Because the x's match, therefore the 7's match, right? Yeah, so in there goes a 7 because they match, right? So let me circle it in my rainbow colored pen. They match. So then this is going to be 7, Miss Johnson? Yeah, the answer is 7. Okay. All right. The next problem they want me to do is number 7. So the graph of f of x, log base 3 of x is shown. Okay. Which point on the graph? Yeah, I know. I know. Sometimes it's like, oh, Miss Johnson, what? That doesn't make sense. And then you see it and you're like, oh, it totally clicks now. Okay. This one sounds really funny, but it'll make sense to you. It says which point on the graph tells you the base of the logarithm. Which point on the graph here tells you what the base of the logarithm is. So do you see log base 3 of x here? And the answer should be yes. Okay. And then you should be looking for good points to use. Now, this is not a good point to use, right? This point right here is not a good point to use because that would be f of 1 equals log base 3 of 1. But do you guys remember this? Log base 3 of 1, what did that always equal to? Do you guys remember from our lesson? Log base 3 of 1. Yeah, that's always going to be 0. Now, notice here, it is also 0 here, right? So it didn't matter what the base was, it's always going to give you, which makes sense, right? Because anything to the 0 is always going to give me 1. Anything 3 to the 0 is always going to give me 5 to the 0 is going to give me 1. So that's not a good point. What's another point here that would make sense? Yes. Okay, for this one, 3, 1 makes sense. Okay, so let's put this guy right here. This point 3, 1 makes sense. Why does it make sense? Because, so let's plug it in. F of 3 equals log base 3 of 3. Oh, that makes sense, Miss Johnson. Log base 3 of 3. 3 to the what gives me 3? Oh, that's 1. So because that exponent is 1, it must mean that that 3 and that 3 matches. Remember, you guys said the base and the argument match. So that point right there is our winner. That's our answer. 3, 1 is the one that tells me about my exponent. Very good. The next number you asked was number 9. Explain why the graphs of the logarithmic functions with bases contain the 0.10. We kind of explained this already, right? So I think you're okay there. Number 10 says the graph of a log function that has been transformed, write the function. Okay, so when you're doing this problem, number 10, this is what we worked on today. Okay, what are the 2 things I should be looking for log functions? What are the 2 things that I should be looking for? The asymptote. Okay, very good. So where's my original asymptote for log base x? Where, if I drew log of x, where is his asymptote? Very good. His asymptote is right here at x is equal to 0. Very good. What's another point that's really significant for log of x is 0? I mean, sorry, of log of x. Yes. The other point that's significant is this point right here at 1, 0. So that's why those were the 2 pieces that helped you build the function. Okay, and I'll show you the last little pieces that'll help you build out this function. Okay, so first of all, I'm looking for basically 3 things. And the third thing actually now should make more sense from this question right here. I'm looking for, did my asymptote shift? So you guys answer that. Did my asymptote shift? So did my asymptote shift? Look at this graph right here and this asymptote right here. Did it shift? Yeah, no, it didn't shift. So because it didn't shift to the left or to the right, that means I don't have an like the x minus 2 or x plus 2, right? I don't have a translation in the x direction, right? So if you look at me, I'm going to build my function, right? F of x equals to log of x. Notice I'm not putting a parentheses with an x plus 2 or x plus 3 or x minus 4. Got it? So far, it looks pretty good. Okay. The second thing that I need to look at is this point. Now, this point right here, it obviously didn't stay there because look at it, it's all the way, it got moved, right? So where do you think this point moved to? Where do you think this point moved to? Yeah. Yeah, it moved to 1, -2. It moved down 2. Now, someone said, Ms. Johnson, couldn't it have moved like to over here? It could have, but remember that for the most part, my point and my asymptote like to stay really close together. Okay. Someone said, Ms. Johnson, are they always going to be 1 unit apart? No, not always. But if you can get a point that's right next to it, then that's the point I'm going to use. Okay, but this is going to be another very significant point, if that makes sense. This point right here is going to be another significant point. Okay, so it moved down 2. It moved down 2. Now, where does that show up in my function? Where does that show up in my function? Yes, it shows up in front, but as a what? How do you write it? Yeah, I'm gonna write it like this. Ooh, I didn't save myself enough space here. Let me scoot this over. That's enough space. So I'm gonna write it like this: -2 plus log of x. So -2 plus. I don't want to do 2 minus because the 2 needs to go down 2. And if you do 2 minus, that 2 is positive, so it'll go up 2, right? So down 2, very good. And the last point that I'll use is this one, which reminds me of these here, right? So if you look, right, if you look at where the point is, I'm going to look at this next point, right? And this next point is at 3, comma, -1. So I'm going to take this point and shift it. See how it's down to here? I'm going to find where that point originally was by undoing this. So if this got moved down to, I'm going to move this up to right here. Right? And then that can help me that will help me tell the base. That's going to help me figure out my base. Exactly. So someone said, Ms. Johnson, is my base 3? Yeah. How do you know? Because it was before it was 3, comma 1. It was 3, comma 1. Does that make sense? So just to make sure, Ms. Johnson, is it okay if we check our answer? Yeah, let's check our answer. So I want to plug in, right? -2 plus log base 3 of x. So you're saying, Ms. Johnson, this one and this one are the same. They don't look the same shape. Yeah, I know. Hold on. So the very first thing I want to do is I want to look at that point right there at 1, comma, -2. Look, it's right there. I want to look at this other point called 3, comma, -1. It's right there. You see that? And so you see how here it crosses it almost looks like exactly at 9, and it does here too, right? Which if you think about that, that makes sense, right? Right. If I plug in a 9 here, when I plug in a 9, log base 3 of 9, 3 to the what gives me 9? Oh, that's 2. So -2 plus 2 is 0. Yeah, right? So this is actually perfect. So when you're looking for the function, these are the 3 things you're going to be looking for. Number 1, did my asymptote shift to the left or to the right? You all said no. That's why I don't have a number inside my parentheses, right? Did it shift up or down? And you guys all said yes, it shifted down to. That's why we have this -2 out in front. How did we find this 3? Someone asked in the chat. How did we find this 3? Can you put that to the public chat? How did we find this 3? Yeah. So if you look at this point here, I wanted to look at it before we shifted it down to. So when I shifted it down to, it is here. But before I did that, it was up here. And from learning what we learned up here, 3, comma 1, right? Basically told me what my base was, right? So you're going to look for, where's that point that hits the line y equals to 1, right? Because that's going to be your base. That makes sense? No, the base is this number here. Oh, yes. So someone said, so the base is the x value of that, yes. Of where it used to be at 1, right? Because that's what we figured out here. Log base 3 of 3 is 1. So that point was there. Now we move it down to, now it lives here. So you almost want to think about undoing the shifts to find those points, right? Again, the 3 points that you want to, or the 3 things that you want to look for when you're writing a log function is the asymptote. This point here, 1, 0, where did you shift to? And then last but not least, the base. And you can do those in any order. I think I would rather you find the base because that'll help you find everything else. But yeah. Okay, so now that you did that one, pause right now, try this one out on your own. Look for those things. Look for your asymptote. Where did that point go? Where did the 1, 0 point go? And where did your, where's that base number? So I'm going to have you try that. Okay, for this one, I asked you to find the 3 things. Find your asymptote, find where that point went, and find where your base helping point is. I don't know what to call that point. So the asymptote for me is the first one that it jumps out for me. The asymptote just jumps out. Here it is right here at x equals -2. right? It's right here at x equals -2. So that tells me that my graph got shifted to the left 2. So because it got shifted to the left 2, how does that play into your equation? How does that play into your equation? So your equation is always going to be log, and then we're going to have this like equals 2, and we're going to put y on the other side, right? Yeah, it plays into it by having an x plus 2 in parentheses. The reason why it's in parentheses is because we shifted in the x direction, and x always goes backwards, -2 plus 2, right? Okay. I'm going to check that using my point. My point normally is right here at 1, 0. And look, it got moved twice to the left. And there it is right there. So far we're in good hands, right? So there's that 2 shift. Okay, I'm going to look for a point that matches up with the 1 where y is 1. And it kind of looks like it's right there. I think that's the best for it. So if I'll use a different color, because that is right here at 3, 1, and that's after it got shifted 2 to the left. Where did it live before it got shifted? Where did it live before it got shifted? Yeah, at 5. So if you undo the shift, right, it lives right there. So that means that my base is 5. So that means my base is 5. Ms. Johnson, why is it 5? It has to do with this up here, right? Because it's 3, 1 tells you it's my base. Same thing goes here. 5, 1 was your base. Again, you'd want to check your answers just to make sure, just so that you're all on the same page. Let's do this next one. Oh yeah. So the graph shows a logarithmic function that has been translated vertically and horizontally. Write a function for this graph. The dotted lines are transformed axes that could help you write this equation. They're basically saying that the axes moved as well, right? You see the axes moving as well? Okay, so go ahead and try this one. I'm gonna write my form out for you. So y equals, then the log, and then I don't know if we're gonna need the x parentheses or not, but I'm gonna put them there. Okay, so what's the first thing that jumps out to you? Yeah, the first thing that jumps out to me too is my, oops, let me switch colors, is this asymptote that is now at x is equal to -5. Before it was at 0, and then it moved left 5. It moved left 5. So because it moved left 5, where does that live in my function? Where does that live in my function? Yeah, it's parentheses x plus 5. Very good. So this is that. This affects that, right? Okay, good. And then if you don't have to use these axes, so I'm going to almost pretend that they're not there. If they help you, great. If not, then don't. The next thing I'm going to do is I'm going to look for this 0.10 that used to be right here. I'm going to look for this point at 10, which used to be here, but now it looks like it's, where is that point? Where is that 0.10? Can you guys find that point for me? Which point should I use as my 10? Where did it move to? -4, -2. Yeah, it moved right here. So because it moved right here, right? Oh, that makes sense, because look, it was here, and then here's the shift 5 to the left, 5 left, right? And then it moved 2 down. Then it moved 2 down, right? So where does that 2 down go again? Where does that 2 down go again in my function? Where does that 2 down go in my function? Yeah, it goes all the way out front here. So it goes -2 plus log. So the last little thing I need is I need my base. The last thing I need is I need my base. So remember here, I'm looking for where it intersects with the y equals to 1 line, right? I'm looking for where it intersects to the y equals 1 line. But if everything's been shifted, where is that line right now? If everything has been shifted, where is that line now? Where's that point, rather, I guess? That's what I'm really asking. Because I really need to find my base, because right now my base could be anything, right? I could put a 10 in there, I could put a 2 in there, and the asymptote would be correct, and that point would be correct, right? So I'm looking at this point right here, right? I'm looking at that point right there. Right. And the reason why I'm looking at that point is because it's a good point, number one. And then as I shift it this way, undoing these, it'll show me where I was before. So if I go 5, not to the left, but 5 to the right, right? I end up over here. And then 2 up would end me up right there. And that's exactly what I would want. I want to know where it crashes into that 1. And so looking at this information here, where's my base? What number do I put here as my base? Yes, very good. Okay, very good. I will put a 3 as my base because look, that's where it is at 3, 1, which makes sense, right? Because it's 5 over. So this point here traveled all the way this way, or sorry, it traveled all the way this way and then all the way this way to follow the directions that it gave, right? And then this is where it ended up. But where it was is how you figure out your base. Where it was is how you figure out your base of 3. Does that make sense? Very good. And then the last question you guys all had was the retrieval question. I think it's going to be down here. So evaluate log base 2 of 128. Very good question. So when I see that question, I think I translate it into exponentials. So I'm going to translate this into exponentials. If you can translate it for me before I get there. So I put equals to box. I take the base of 2. So I say 2 to the box equals 128, right? 2 to the box equals 128. So I'm just going to take my calculator and start multiplying until I get to 128. So 2 times 2 equals times 2, oops, equals times 2 equals, oh, there's 128. So then I can just count my 2's. 1, 2, 3, 4, 5, 6, 7. Oh, it's 2 to the 7. So this is 7. Does that make sense? Yeah, good job. Same thing goes with this one. You'll see that your answer is 3. And then this one here looks crazy, but just go with exponents. Every time you see a negative exponent, it wants to divide by that. Okay. Don't get tripped up because your exponents can't see this 5. And you should remember why. The exponents can't see this 5 because it's only being applied to that x. So the way I do this first part is it's 5 to the -2nd, x to the 6th. So I multiply these exponents here, right here. I need this to catch up. Okay, this one, don't be tricked. is going to be 5 over x to the 4th. 5 over x to the 4th. Ms. Johnson, why does I put 5 to the 4th, my bad. Why doesn't the 5 go to the bottom? Why aren't you doing? Because because 5 has its own exponent. What is its exponent? Yeah, it's an invisible 1, right? And because it's an invisible 1, it doesn't get divided by 5, right? So I'm going to change this around so it's divided. So I get x to the 6th is the same, 5 squared is the same, 5 over x to the 4th. Okay. And then I just simplify. So I have a 5 on the bottom, and then I have an x squared on top. So there's my answer. So x squared over 5.